Whenever a calculation asks about an acid and an alkali and mentions the words neutralization or titration, we can carry out a titration calculation. This involves a balanced equation and the use of the triangles that we learned beforehand. Here are 5 steps to complete titration calculations. Step 1. Balance the equation. Step 2. Work out the mole ratio, the ideal mole ratio. Step 3. Calculate the number of moles that you actually have. Step 4. Calculate your actual mole ratio. And step 5. Calculate what the question is asking you. In a titration calculation, this is usually asking you to calculate the concentration of one of the solutions. Here we will work through an example of a titration calculation. 20 centimetres cubed of 0.1 mole per litre sodium hydroxide is required to completely neutralise 10 centimetres cubed of sulphuric acid. What is the concentration of the sulphuric acid? So your first step is to see if this equation is balanced, and just by having a quick look we can see that it's not, because on the product side we have 2 sodiums and on our reactant side we only have 1. We've now balanced our sodiums, however we now have 2 oxygens and 4 hydrogens on our product side, whereas on our reactants we've only got 1 oxygen and 2 hydrogens. So we must place a big 2 here to balance our equation. The 2 species that we are looking at in this from this equation are sodium hydroxide and sulphuric acid, so we can rewrite that. For step 2, we have to show our mole ratio. Big 2 at the front means that we have 2 moles of sodium hydroxide, and we have no number in front of our formula here, so we just have 1 mole of sulphuric acid. For step 3, we must calculate the number of moles of sodium hydroxide that we actually have. To do that, number of moles equals concentration times volume. Concentration we can lift directly from the text at the top. It was 0.1 moles per litre, and our volume was 20 centimetres cubed. Now when we're doing these calculations we never work in centimetres cubed, we work in litres, so we have to divide by 1000 to get that value into litres. 0.1 times 0.02, and our answer there is 0.002 moles. We then bring the number of moles of sodium hydroxide that we've calculated up, and we calculate the actual mole ratio. So instead of 2 moles we have 0.002 moles, which means that instead of having 1 mole over here, we're going to have 0.002 times 1 divided by 2. And that gives us 0.001 moles of sulphuric acid. On to our final step. We are calculating the concentration. Concentration equals the number of moles divided by the volume. The concentration we calculated to be 0.001 moles divided by our volume, which is 10 centimetres cubed. Again, we must divide that by 1000 to put it into litres. And there, our final answer for concentration of sulphuric acid is 0.1 moles per litre. Let's work through our second example. What is the concentration of hydrochloric acid if 37.4 centimetres cubed is neutralised by 25 centimetres cubed of sodium hydroxide, concentration 0.1 moles per litre? First step is to check that our equation is balanced. And here we can see that it is. Our second step is to rewrite out what species we're interested in and work out our mole ratio. So we're interested in hydrochloric acid and our sodium hydroxide. So if we rewrite that, we can see that we have a 1:1 mole ratio. Step 3, we have to work out the number of moles that we actually have of sodium hydroxide. Our concentration is 0.1 moles per litre, that's taken straight from the information at the top, and our volume is 25 centimetres cubed. We must divide this by 1000 to get it into litres. So here we have calculated that we have 0.0025 moles of sodium hydroxide. We then bring this up to step 4 when we're calculating our mole ratio. It's a 1:1 ratio, so we have 0.0025 moles of hydrochloric acid as well. For our final step, we're calculating the concentration of hydrochloric acid. Concentration is number of moles divided by volume. We were given a volume of 37.4 centimetres cubed in the question, and we have to divide that by 1000 to get our volume into litres. And once you do that calculation, you'll find that you have a concentration of 0.0668, so on and so forth. You have 0.07 mole per litre solution.